Okay, ladies and gentlemen, what we want to do is we want to talk about tying up all of the different loose ends that we have for lines. Now, we already know the slope formula, m equals y2 minus y1 over x2 minus x1. We know slope y-intercept form, y equals mx plus b. Point slope form, y minus y1 equals m times x minus x1. That's point slope. And finally, standard form, ax plus by equals c. Now, the nice thing is, even if we're given something as basic as 2 points, 3 comma 5, 2 comma 9, the first thing we're going to want to do with those 2 points is I could graph them actually fairly easily. And to graph them, all I would literally need to do is go over 1, 2, 3, 1, 2, 3, 4, 5, and then over 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. And I can graph that line without any equation whatsoever. But to get an equation, I'm going to need the slope. Now, the slope I could do by putting either point first, and that's going to give me -4. Once I have the slope and I have these points, I could use either intercept or point slope to actually find the equation. So in this case, let's go ahead and use slope y-intercept form. Y equals, well, put the -4 in for slope, -4x plus b. Then let's pick a point, I don't know, 3, 5, and plug it in. So 5 goes in for y, 3 goes in for x, and you get 5 equals -12 plus b. Move the 12 over, you get 4x plus 17. Now, you say, well, but wait a minute, if I have a point and a slope, why don't I just use point slope form? Wouldn't that be a lot easier? Well, actually, yes. Take the slope, put it right where it belongs. Take the y, put it where it belongs. The x, put it where it belongs. And there you go. You have the slope and point slope formula. Now, with that in mind, you say, but how do I know these two are the same? Well, if I distribute out the -4, I get this, move the 9 over, and in fact, it turns into be exactly the same. But we have a couple other equations that we need to add to our list. To add those to our list, what we need to do is we need to say x equals number and y equals number. Those are two different equations that are special examples. For the line x equals number, 1, 2, 3, for example, x equals number, x equals 3 in this case, is a vertical line. Now, if I have y equals number, 1, 2, 3, here we go. In this case, y equals -3. That also is a special line, but it's horizontal. Now, what's weird is that x equals number goes up and down. Y equals number goes left and right. The reason that that's weird is because we're used to the y-axis going up and down and the x-axis going side to side, which is true, but we also have to have the fact that these lines always have points on them. And these points, the reason this line is x equals 3 is because the points on this line, 3 comma number, negative puts it down here. 3 comma number positive puts it up here. But it means that the x is always 3 no matter what. Likewise, down here, it's going to be number comma -3. Over here, it's number comma -3. The y part is always -3. So vertical and horizontal lines are special conditions that we need to make sure that we remember. Additionally, if I have two lines that are parallel, it means they're going in the same direction and never cross. But as soon as I put them on a set of axes, I see that parallel lines have to have the same slope. Because if they don't have the same slope, then they're going to be going at different angles. So if I have something like this, I want what is a line parallel to y equals 3/4 x plus 2 through 4 comma 10. With this in mind, with this in mind, we want to have parallel to this line, but through the point 4, 10. So we need to find the equation of this line. To do that, it's actually pretty easy because if it's parallel, the slope has to be the same, so I'm going to steal it. I have a point, I'm going to steal it. So now all I need to do is figure out what goes in those boxes right there. And the answer is, of course, well, the 10 goes here, the 4 goes here, and our slope goes right there. With that in mind, we now have a line that is parallel to this equation through this point. What happens if I want a line that is perpendicular to y equals 3/4 x plus 2 and goes through the line 4 or the point 4, 10? In that case, what we need is we need to know, well, what does perpendicular mean? Well, parallel meant that 3/4 equals 3/4, and it was parallel because they have to be the same. Perpendicular means we're going to take the 3/4, and if you'll remember, we have to flip this over and switch the sign. So perpendicular, that's the symbol for perpendicular, is the opposite reciprocal. So in our case, y minus something equals something, x minus something. So in this case, we're still going to put the 10 here. We're still going to put the 4 here. But now for the perpendicular slope, instead of 3/4, flip it with the negative, -4/3. And with that in mind, we can now graph these two lines. So let's go over 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have a slope of 3/4. 1, 2, 3, 1, 2, 3, 4. And is that parallel to the original? Up 1, 1, 2, up 1, 2, 3, 1, 2, 3, 4. Those two look pretty parallel. That's true. Y equals 3/4 x plus 2. Y minus 10 equals 3/4 x minus 4. Now let's do the perpendicular line. Well, I still have 4, 10, so that's right here. But now the slope is -4/3. 1, 2, 3, 4, 1, 2, 3. And in this case, I have this line. So we have y minus 10 equals -4/3 x minus 4. Does that look like it meets at a right angle? It certainly does. So by using parallel and perpendicular, we can finish up our discussion of linear equations.